Figure 1 shows the motion of simple pendulum of length L. Part A. Write down an expression for the period of oscillation T of the simple pendulum in terms of L and acceleration due to gravity G. T equals 2 pi root L over G. Part B. In the laboratory experiment, to find the value of G using simple pendulum, you are provided with a stopwatch which can measure the time with an accuracy 0.5 seconds. If the estimated value of the period is T, 2 seconds, determine the minimum number of oscillations you should take to reduce the percentage error T down to 1%. We can consider percentage error. Percentage error means period error of maximum error of instrument. I will write the equation. Percentage error equals to maximum error, or we can consider it is equal to the least count of the instrument. For an instrument, maximum error equals to least count of the instrument. Maximum error divided by reading multiplied by 100%. Now percentage error should be 1%. Maximum error is given as 0.5 seconds. It is the least count of the stopwatch. Now we have to get reading. When getting reading, we can consider approximate period is given as 2 seconds. If we are using n number of oscillations, 2 times n is the reading, multiplied by 100%. Now we can subject n value. 0.5 into 150 divided by 2, 25. We have to obtain period for 25 oscillations or greater than 25 value. In part C, the student has designed an electrical method to determine the period of oscillation T more accurately by using a detector system. They have given a diagram: source diode, detector diode, and IR beam. There is a IR beam from source diode to detector diode. When covering the IR beam by the pendulum, it is detecting by the detector diode. The detector system consisting of source diode and detector diode. Source diode emits a narrow beam of infrared light with constant intensity I0. The light beam is detected by the detector diode. It also measures the simple pendulum, measures the intensity of beam. Detector system is placed in the path of bob of the simple pendulum. While oscillating, the bob also crosses the IR beam. Whenever the bob interrupts the IR beam, detector diode signal becomes zero, otherwise produces a signal of constant intensity I0. When the bob is oscillating, the computer monitor displays a graph of variation of detector signal intensity I with time. Figure 3 shows such a graph displayed on the computer screen, and is taken in a situation where the force due to air drag is negligible. The time interval corresponding to the zero detector signal is T0. Part 1. Value of T0 depending on speed of V with the bob cross the IR beam and diameter d of the bob. What will happen to the value of T0 when part 1 V increased, part 2 D decreased? Now we have to consider given graph. There is a constant intensity, and when covering the IR beam, the intensity becomes 0. Again, intensity becomes the previous time. They have given that this time interval is T0. And we have to write what happened to T0 when velocity increased. In part 1 they have asked when velocity increased. When velocity increased, the covering time is decreasing. Therefore, we can write T value, T0 value decreases. In second part, when D increased, D means diameter of pendulum bob. When diameter of pendulum bob is increasing, the covering time is increasing. Therefore, T0 increases. Part 2, write down an expression to estimate V in terms of D and T0. We know that T0 time is the time taken to move pendulum bob D distance. If the IR beam is in this space, it should move from this position to this position within T0 period. It means distance moved by pendulum bob is D. Then we can write velocity equals to distance divided by time, displacement divided by time. Corresponding displacement is D, time is T0. Now it is the relationship for velocity of pendulum bob. Part 3, what is the value of T according to the graph given in figure 3 above? We can consider the given graph. After passing this position, it means pendulum bob is passing the detector at this time, and again it will come to the same place at this time. Therefore, time interval between these successive zero values is the half of period. The time taken to move from this place to again this place. Then we can use 2 times of this length is the period. It is 3 seconds. We can observe the graph and we can find it. Then answer for part 3 is 3 seconds. Then part D, the student places a detector system at the most appropriate position of the path of the bob to determine the maximum speed Vm of the bob and obtain the graph similar to the graph shown in figure 3. With respect part 1, with respect to figure 1 above, give the position of A or B at which the student keeps the detector system in order to determine Vm. Give reasons for your choice. You have to consider figure A, sorry, figure 1. We have to place detector at A. And we have to write the reason. We can observe A means midpoint of the path, oscillating center. This one is A. We can observe maximum speed of the bob at A. Therefore, time measurement, error of time measurement is a minimum value. Then we can write there is a maximum speed at A, therefore error of time measurement is a minimum value. In part 2, in order to carry out this expression, the student says that the cylindrical bob shown in figure 4a is better than the spherical bob shown in figure 4b. If both bobs have same diameter d, give reasons for justify the statement. Yes, it is correct because of if we are using cylindrical bob, we can place detector system for any height of this cylinder. But if we are using diameter, we have to get the reading by placing detector system across this diameter. It is difficult to get practically. Then we can write, we can't see the IR beam. Therefore, we can't place correct position when using spherical one. Then we can write IR beam is not visible. Therefore, it is difficult to place correct level of spherical bob. Part 3, the student decides to calculate Vm using the graph mentioned above and the expression in C2. Can he get the exact value of Vm by this method? Explain your answer. No, he can't get correct velocity because of he can observe readings for the maximum velocity position. Velocity is changing with path. Therefore, you can write Vm is an instant velocity, but he has to take average velocity. Velocity of pendulum bob is changing with path, therefore changing with the position, therefore he has to use an average velocity as the correct value of velocity. By getting the previous method, it means V equals d over t naught equation, he can get only the velocity at oscillating center. Then part E, the student observed that a situation where the force due to air drag is significant, the maximum speed Vm that obtained decreases continuously from the oscillation to oscillation and bob finally comes to rest. Part 1, for such a situation, complete the graph I with t that you would expect for the period of time t on the figure given below. Now velocity reduces. Therefore, when considering this time, it should be less than the second time period of oscillation. It means second time interval when passing the bob the detective system. we are reducing it to the third one, period of oscillation is constant. Therefore, this gap is not changing, but velocity decreases. It means we have to increase this t0 time interval, oscillation by oscillation. In part 2, if the maximum speed of the bob at t equals 0 and t equals t, t means period, are 0.44 meters per second and 0.42 meters per second respectively, estimate the energy of the pendulum due to estimate the loss of energy. It should be loss of energy of the pendulum due to air drag during the time t equals 0 to t equals t. Mass of the bob is given as 100 grams. Now we have to consider the equation for kinetic energy. We can write energy loss half mu squared minus half mv squared. I will consider half m as a common factor. Half into mass of pendulum bob is 100 grams. It means 0.1 kilograms. We can write this difference between two square terms as v plus u and u plus v and u minus v. Then half into 0.1 into u value is 0.44 and v value is 0.42. We have to add it. 4 plus 2 6, 4 plus 4 8, 0.86. Then we have to subtract 0.02. Then we can cancel out and we can get the answer 8.6 into 10 to the power minus 4 joules. It is the energy loss.